So today we're going to see some more proportions for our similar triangles. So on the first slide, we have the triangle proportionality theorem. And what this theorem states is if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Now, they've shown us one example of how you could set up your proportion. However, you can do this in numerous different ways. So I'll show you some other proportions of what we can do here. So let me just label my pictures so when I start talking about top and bottom, left side, right side, you know what I'm referring to. So I'm going to refer to this as the left top. This would be the right top. This would be left bottom. And this would be right bottom. Because what the theorem states is it divides the sides proportionally. So the way that they have set up their proportion is they've done the right top over the right bottom, and then set that equal to the left top over the left bottom. So notice the tops of their fraction come from the tops of the triangles, and then these are both the bottoms. So these are right, right, left, left. Now, you could have also flipped it if you would have rather put the left side first, AE over ED, AB, BC. This is the same thing, I just flipped the sides. Now, you can also do top over top, so I could do left top over right top, and then I could do it this way. So I could do it top over top, and then bottom over bottom, so left bottom over right bottom. And I'm going to do these with the letters now. So let's say I'm going to do AE, which is my left top, over my right top, which is AB. And then I could do, so these are top over top, and then bottom over bottom. So then here I could do ED over BC. So now these are both the tops, and these are both the bottoms. Either way. So keep in mind that what sometimes you may have to do on some of the homework questions is do the same thing that we've done in previous lessons, where we take the little piece off the top, AEB, and now we're referring to A, B, no, that's a D, DC. So again, the A's are the same. Notice these are parallel. So we would have corresponding angles here. And you could do it on this side also. So I could show that these triangles are similar by my AA similarity postulate, and that's why I can set up all these proportions. So if they were to ask you about EB or DC, you would have to refer back to what we did prior to this lesson. What the theorem states is that EB is parallel to DC, and then I have a transversal here, and these are corresponding angles. And then the same thing over here, because these are my parallels and then my transversals. So that's how I could show that the triangles are similar by the AA similarity postulate. Does that make sense? So just stay consistent. If you're going to do left top over left bottom and then right top over right bottom, just make sure you're staying consistent. Or if you're doing top over top, you need to do left over right, left over right. Just stay consistent. the converse of the triangle proportionality theorem is on the next slide. And this is where we're going to switch the if and the then. So the converse states, this time, if a line divides two sides of a triangle proportionally, then it's parallel to the third. So again, now they'll start by giving us the proportion, and then we can prove that the lines are parallel. So this would be the converse of the triangle proportionality theorem. And we're going to apply the triangle proportionality theorem on the next slide with the next example. So here's our example. Now, for both, for A, let's go ahead and set up our proportion. Notice they've already started it for us. So we don't have an option that we could change it. So here they're doing CD, which is this bottom portion, and they're putting it over this top portion. So when I go to write the equivalent, I am going to say that CE, the bottom part, over the top part of the left side. Now for part B and for part C, they're changing the numbers. So I'll first do the problem for part B, and then I'm going to erase it and then put in the numbers for part C. So let's do part B first. So they're telling me that CD is equal to 3, DA is equal to 6, DE is equal to 3.5, and they want me to find AB. Now, if you recall, that triangle proportionality theorem only divides the sides proportional. So for this problem, I need to pull my triangles apart, and then I need to match the corresponding sides. So for example, if I take the large triangle, the BAC, here's what they're asking me to find is AB. I can see that the length from A to C is equal to 6 plus 3, which is 9. Then I'm going to take the little triangle here, the CDE. I knew this side is 3.5, and I know this piece is 3. Now, I know that these triangles are similar because I can do it by, let's see, an example. We can set it up proportionally. I could do side angle side here. Let's see, what else could I do here? I have angle C, that's in common. And then I could set up my proportion for the rest. So let's go ahead and set this up. I'm going to do this side of the triangle and this side. So x over 3.5 is equal to this side and this side. So 9 over 3. I'm going to cross multiply and divide. So 3x is equal to 3.5 times 9. And this will give me 3x equals 31.5. Divide by 3. And x equals 10.5, which is what AB is. Now for part C, I'm going to erase all those labeled sides. Actually, I could redraw it down here. Let me do that. Let me redraw it. Yes?
Could you change 9 over 3 to 3 over 1?
Yes, you could. So if you wanted to simplify the 9 over 3, that's a good point to bring up. You can simplify the fraction and make this 3 over 1. And then it's not so difficult. All you're going to do is multiply 3.5 times 3. That would be an excellent idea, especially those of you who are struggling with the multiplication and the division. You can simplify the fraction itself. Do not try to simplify diagonally. All right, so let me just go ahead and redraw this, and I'm going to put in my new numbers that are given to me in part C. All right, so this time for part C, they told me CB is going to be 12. So this whole thing is 12. EB, this little piece, is 8. CD is 6. And they want me to find AD. Now, I can set this up proportionally. And I can either do BE over EC, do top left over bottom left equals AD over DC, or I could do tops BE over AD and EC over DC. Either way. Now, so in order to do this, I need to find the length of EC. How can I find out how long this little piece is? Anybody have any ideas? Yes. Beautiful. Okay, I knew the whole side there, BC, was 12, and I knew the little piece BE was 8, so 12 minus 8, and EC is 4. Now I can choose one of these proportions and solve. So if I do the first one, it's 8 over 4 is equal to x over 6. I can simplify the 8 over 4 and make it 2 over 1, cross multiply, and get x equals 12. Now, I could also use this one. My BE is 8, my AD is x, my EC is 4, and my DC is 6. Again, I could simplify the 4/6 to 2/3. Get 2x equals 24, divide by 2, and x equals 12. Now, if you don't like simplifying, you could have also solved this same one and got 4x equals 48, divide by 4, and x equals 12. Either way, notice no matter how I solved or set up my proportion, each time I got the same answer, and I got 12. Here's another proportionality theorem. Again, this one doesn't have a name, and again, the number 6.6 doesn't mean anything to us. You need to memorize what the theorem states. Yes?
So there's no name for it?
No. So you need to be able to restate it. And what it says is if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Yes?
Can we use like symbols?
Yes, you could use like parallel lines. Yes, you could abbreviate. So their proportion, they've set it up with the tops over the bottoms. So they're saying BC over its bottom, which was CD, and then AF over FE. Now, we can also set this up from side to side. So I could also say AF over BC, and then FE over CD. So I could also go side to side. Or I can go, instead of top to bottom, I could also go bottom to top. So this way I could say EF over AF and DC over BC. It doesn't matter, just stay consistent within your fractions. Yes?
You go AF divided by FE is equal to BC divided by CD.
AF divided by,
FE.
and then BC divided by CD? Yeah. Yeah, that's what, so they just flip-flopped it. So like if you took this and wrote this in the front, that's what you just asked. Does that make sense?
Yeah.
Okay. All right, let's try an example of this. So again, they're giving us different numbers. So let me go ahead and label for part A. A equals 2. B equals 3. C equals 5. And we don't know D. Now, a whole bunch of different ways that we can set this up. So we can either do top to bottom. So 2 over 3. 5 over D. I could also do side to side. I could do 2 over 5, 3 over D. I could flip it and say 5 over 2, D over 3. I could flip this one and say 3 over 2, D over 5. Any of these are going to work. So let's go ahead and solve one of them. So let's say I solve this one. So 2 times D equals 3 times 5. 3 times 5 is 15. Divide by 2. And D equals 7.5 or 7.5. Now I'm going to change the numbers. This time they're telling me that A is 4, B is 8, C is still 5. This time they want me to find C plus D. So I can do it exactly the same way, use any of those proportions, but once I find D, I need to go back and add that to C. So let's say I decide to do top over bottom, so 4 over 8, 5 over D. Again, you can simplify the 4 over 8 if you like, make it 1/2, and then you get D equals 10. Again, they wanted C plus D, so C was 5, I just found D to be 10, so C plus D is 15. Now, another way you could do it is you could say, I'm going to introduce a new variable and say this C plus D is going to be equal to X. So another way we could do it is take 4 over the whole total, which is 12, and then 5 over the whole total, which I'm calling X. So for X equals 60. Divide by 4, and X, which is really equivalent to C plus D, is equal to 15. Same answer I got when I found D separately. I just needed to remember to go back and add it to C. Last theorem, again, it's got a number. Number's not important to us. What's important is what it states. And this says that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other 2 sides. So here is my ray, and it's bisected my angle, and I can tell that it bisected it because I have 2 congruent pieces here. And then the side that's opposite that bisected angle, these are going to be proportional to the other 2 sides. So what they've done here is taken this piece, AD, and put it on top of the other piece that it split, and then they take the 2 sides and put them on top of each other. That's one way you can set up your proportion. Another way would be to take the CA, this side, and put it on top of the side that's right next to it. So you could put on top of AD. Then again, we'll take the side and put it on top of the piece that was split in two. So CB over DB. Cross multiply and divide. You could reverse it if you'd rather put the piece on top over the side, and then the piece on top over the side. Either way, all of these will give us the same answer. And let's try an application of this. So it wants us to find the length of x, the whole side there. So I'm going to go ahead and throw in and say that this little piece here is going to be called y for me. And then what I'm going to do is after I find y, I'm going to go back and add it to the 10. And then that'll give me the length of x. So again, we can do this multiple different ways. I could take this side, put it on top of the piece that was split, and then this side on top of here. So if I do 12 over 10, 24 over y, I can simplify 12 over 10, make it 6 over 5. 6y equals 24 times 5 is 120. Divide by 6, and y equals 20. So this piece is 20. So to find x, I'm going to do 10 plus 20, so x will equal 30. Another way you could set up your proportion is you could do the two pieces. You could do 10 over y, and then the two sides. Simplify the 12 over 24 into 1/2 and get the same answer. Y equals 10 times 2, which is 20. Another way you could have done this, if you didn't want to introduce another variable, you could have said, well, instead of calling this piece y, I could call this x minus 10. And you can set it up that way. So you could do 24 over x minus 10, and then 12 over 10. I could simplify and make this 6 over 5, and I could multiply, subtract or add. 6x equals 180, divide by 6, and then this would give me the whole length, which is 30. So again, a variety of different ways to go about finding these missing pieces. My advice to you is when you're doing this on the test, show me your proportions. Okay? If I can't see any work or how you've gotten to your answer, there's no way I could even go back and even attempt to give you partial credit. That concludes chapter 6. So you can go ahead and start your homework, and if you have questions, you can let me know.